*row 1.text, notepad window, text editor, editing. Remember, this is not teaching man teacher. Microsoft Candidate UI, pane. It is useful for recalling when exam coming man student. Blank. Based on G scheme for Electronics Engineering Group. Subject, Advanced Communication System, 17656. These are mostly important questions which is always repeat, form. Top to end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter. Download link is below.
One. Advanced Communication System Chapter 1. Answer 1. Draw field pattern of circular waveguide. ANS. Advantages. Any 2M. The circular waveguide are easier to manufacture than rectangular waveguides, and are easier to join. The TM01 modes are rotationally symmetrical, and hence rotation of polarization can be overcome. TE01 mode in circular for long-distance waveguide transmission. Disadvantage. Physical size is the primary lower frequency limitation. It is difficult to install. Applications. Any 2M rotating joints in radars to connect the horn antenna feeding a paraboloid reflector, which must rotate for tracking. TE01 mode is suitable for long-distance waveguide transmission above 10 GHz, short and medium-distance broadband communication, cold replace/share coaxial, and microwave links. It is used where the transmission or reception is in the range of microwave frequencies. It is also used for handling the high power of energy. It is mostly used in the airborne radar. 2. Advanced Communication System Chapter 1. Answer. The circular waveguide is mostly used in the ground radar to transmit or receive the energy from antenna, which revolves in 360-degree bearing continuously. The waveguide is also used in communication system. It can also use in the devices of navigation aids. The circular waveguides are also used with the cavity resonators to carry the input and output signals. 2. Draw field pattern of TE1.0 mode in rectangular waveguide. ANS, diagram 6M. Or 3. Compare waveguide and 2-wire transmission line, 8 points. 3. Advanced Communication System Chapter 1. Answer. ANS, 1/2 M each, comparison. SR. No. Waveguides transmission lines. 1. It acts as a high-pass filter all frequencies can pass through. 2. TE and TM modes exist in WG. TEM mode exists in TL. 3. It is one conductor transmission system. The whole body of the waveguide acts as ground. The wave propagates through multiple reflections from the walls of waveguide, WG. It consists of 2 conductors. One or both conductors are used to carry the wave. 4. The system of propagation in waveguide is in accordance with field theory. The system of propagation in transmission line, TL, is in accordance with circuit theory. 5. Wave impedance, characteristic impedance, is a function of frequency. Characteristic impedance in TL depends on the physical parameters of TL. 6. The velocity of propagation of wave in Wg is less than the free space velocity. The velocity of propagation of waves is equal to free space velocity. 7. Wg handles greater power and possesses less resistance. TL handles less power as compared to Wg. 8. Lower signal attenuation at high frequencies than TL. Significant signal attenuation at high frequencies due to conductor and dielectric losses. 4. A rectangular waveguide is 5 cm by 2.5 cm. Calculate the cutoff frequency of dominant mode. ANS, Formula 1 marks, substituting 1 marks, 2 marks answer. The dominant mode of a rectangular waveguide is the TE1,0 mode, with M equals 1 and N equals 0. 4. Advanced Communication System Chapter 1. Answer. Or 5. State function of following waveguide components: isolator, circulator, cutoff frequency of a waveguide, guide wavelength, phase velocity, group velocity. ANS, diagram 2 marks, function 2 marks, function, isolator. An isolator is a 2-port device which provides very small amount of attenuation for transmission from port 1 to port 2, but provides maximum attenuation for transmission from port 2 to port 1. This is very desirable when we want to match a source with a variable load. When an isolator is inserted between the microwave generator and the load, generator is coupled to the load with zero attenuation, and reflections, if any from the load side, are completely absorbed by the isolator, without affecting generator output. 2. Circulator. A circulator is a 4-port microwave device, which has a property that each terminal is connected only to the next clockwise terminal. They are useful in parametric amplifiers, tunnel diode, amplifiers and duplexers in radars. 5. Advanced Communication System Chapter 1. Answer. Cutoff frequency of a waveguide. It is the frequency of the signal above which propagation of waves occur. Therefore, lowest frequency, which can propagate on the waveguide, is FCTE10. No energy can propagate in a rectangular waveguide at a frequency below FCTE10. This is absolute cutoff frequency of the waveguide. Guide wavelength. It is defined as the distance traveled by the wave in order to undergo a phase shift of 2 pi radians, where lambda equals wavelength of the signal, equals cutoff wavelength 2. Phase velocity. Phase velocity is defined as the rate at which the wave changes its phase in terms of the guide wavelength. Or the phase velocity is the velocity with which the wave changes phase in a direction parallel to the conducting surface. The phase velocity is given by equation where cis velocity of light is free space wavelength, 0 is cutoff wavelength. 6. Advanced Communication System Chapter 1. Answer. Group velocity. Group velocity is defined as the rate at which the wave propagates through waveguide. Group velocity is given by equation 6. Draw and describe the working of E-plane T. ANS, diagram -2M, explanation 2M. Explanation. The E-plane T is a voltage or series junction. Each junction is symmetrical about the central arm, so that the signal to be split up is fed into it or signals to be combined are taken from it. Some form of impedance matching is required to prevent unwanted reflections. When mode is made to propagate into port 3, the two outputs at port 1 and port 2 will have a phase shift of 180 degrees as shown in figure A. Also, when powers entering port 1 and 3 are in phase opposition, maximum energy comes out of port 2. An input at port 2 equally divides between ports 1 and 3, but introduces a phase shift of 180 degrees between the outputs. Hence E-plane T also acts as a 3 dB splitter. 7. Draw the constructional diagram of isolator and illustrate its operation. ANS, 2M diagonal, 2M explanation working. It provides very small attenuation for transmission from port 1 to 2. But provides very high attenuation for transmission from port 2 to 1. In most microwave generator the output amplitude tends to fluctuate with change in load impedance. Fluctuations occur due to mismatch of generator output to load that results reflected wave from load. That reflected wave causes instability of 7. Advanced Communication System Chapter 1. Answer. Amplitude and frequency of microwave generator. If isolator is inserted between generator and load, then generator is connected to load with zero attenuation and reflection. If any reflection generated from load side, then those are completely absorbed by isolator without affecting generator output. Therefore generator appears to be matched for all loads. Or 8. Explain the concept of dominant mode in waveguide. ANS, explanation 4M, explanation. The walls of the waveguides can be considered as nearly perfect conductors. Therefore, the boundary conditions require that electric field be normal, i.e., perpendicular, to the waveguide walls. The magnetic fields must be tangential, i.e., parallel to the waveguide walls. Because of these boundary conditions, a zero subscript can exist in the TE mode, but not in the TM mode. For example, TE10, TE01, TE20, etc. modes can exist in a rectangular waveguide, but only the TM11, TM12, TM21, etc. modes can exist. Also, the cutoff frequency relationship shows that the physical size of the waveguide determines the propagation of modes depending on the values of M and N. The minimum cutoff frequency for a rectangular waveguide is obtained for a dimension A greater than B for M equals 1 and N equals 0, i.e., TE10 mode is the dominant mode for a rectangular. 8. Advanced Communication System Chapter 1. Answer. Waveguide, since for TMMN modes M#0 or N number 0, the lowest order mode TE10 is the dominant mode for A greater than B. 9. Describe TE and TM modes in rectangular waveguide. TE mode. The TM modes in a rectangular guide are characterized by EZ equals 0 and Hertz is not equal to 0. Z component of magnetic field Hertz exists to transmit energy in the guide. For rectangular waveguide, TE10 mode is dominant mode. It signifies all electric fields are transverse to the direction of propagation, and not longitudinal electric field is present. There is longitudinal component of magnetic field, and so TM waves are also called HMN waves. Above graph shows the field variations in a waveguide for TE10, TE20 mode. The electric field exists only at right angles to the direction of propagation. The electric field is maximum at the center of the waveguide, and drops off sinusoidal to zero intensity at the walls. TM mode. M indicates the number of half-wave loops across the width of the guide, N indicates the number of loops across the height of the guide, or no E-field patterns across B dimension. In above graph's value of N is 0. 9. Advanced Communication System Chapter 1. Answer. Choose the dimension of a guide in such a way that for a given input signal, only energy of the dominant mode can be transmitted through the guide. Figure shows magnetic field caused by half-sine E field. In figure, the magnetic field is in the form of closed loops, which lie in planes normal to electric field, i.e. parallel to the top and bottom of the guide. The magnitude of the magnetic field varies in a sine wave pattern down the center of the waveguide in time phase with the electric field. Time phase means that the peak H lines and peak E lines occur at the same instant in time. Whenever two or more modes are having same cutoff frequency, they are said to be degenerate modes. In rectangular guide TM and TMMN are always degenerate modes. TM mode in rectangular waveguide, transverse magnetic mode in rectangular waveguide, is characterized by the Hertz equals 0 and EZ is not equal to 0. Here Z component of an electric field exists to transmit energy in the guide. Fields exists in discrete patterns. All field components have sinusoidal amplitude variations in X and Y directions. In TMMN, subscripts M and N represent number of half-sinusoidal cycles of the field amplitude in X and Y directions respectively. For the existence of TM mode, both indices M and N have to be non-zero. So TMMO and TMON modes cannot exist. 10. Advanced Communication System Chapter 1. Answer. On the waveguide walls, the tangential components of the electric field is 0, and the tangential component of the magnetic field is maximum. 10. Distinguish microwave circulator and isolator with the following parameters: function, construction, application, number of ports ANS, 1M for each point. Senior. No. Parameter circulator isolator. 1. Number of ports circulator is usually more than 2 for port microwave device. Isolator is a 2-port microwave device. 2. Function. It has peculiar property that each terminal is connected to next clockwise terminals. That means port 1 is connected to port 2 only and not to port 3 and port 4. It uses property of Faraday's rotation in the ferrite material. It provides very small attenuation for transmission from port 1 to 2, but provides very high attenuation for transmission from port 2 to 1. 3. Construction. For application, circulators are used in parametric amplifiers, tunnel diode amplifiers, and duplexers in radars. Isolators are used in the output of an amplifier that is sensitive to its load conditions. In UHF or VHF transmitters. In radio transmitters. 11. Differentiate between circular and rectangular waveguide. ANS, any 4 correct points, 1 mark each. Senior. No parameter circular waveguide, rectangular waveguide. 11. Advanced Communication System Chapter 1. Answer. 1. Diagram. 2. Dominant mode TE11 TE10. 3. Manufacturing, easy difficult compared to circular. 4. Attenuation, less more. 5. Cutoff wavelength, low high. 6. Power required, high low. 12. Distinguish microwave circulator and isolator with the following parameters: function, construction, application, number of ports ANS, 1M for each point. Senior. No. Parameter circulator isolator. 1. Function. It has peculiar property that each terminal is connected to next clockwise terminals. That means port 1 is connected to port 2 only, and not to port 3 and port 4. It uses property of Faraday's rotation in the ferrite material. It provides very small attenuation for transmission from port 1 to 2, but provides very high attenuation for transmission from port 2 to 1. 2 Construction. 12. Advanced Communication System Chapter 1. Answer. 3 Application and circulators are used in parametric amplifiers, tunnel diode amplifiers and duplexers in radars. Isolators are used in the output of an amplifier that is sensitive to its load conditions. In UHF or VHF transmitters. In radio transmitters. For a number of ports, circulator is usually more than 2 for port microwave device. Isolator is a 2-port microwave device. 13. Distinguish microwave circulator and isolator with the following parameters. Function construction 3, application 4, number of ports. ANS, 1M for each point. Senior no. Parameter circulator isolator. 1. Number of ports circulator is usually more than 2 for port microwave device. Isolator is a 2-port microwave device. 2. Function. It has peculiar property that each terminal is connected to next clockwise terminals. That means port 1 is connected to port 2 only and not to port 3 and port 4. It uses property of Faraday's rotation in the ferrite material. It provides very small attenuation for transmission from port 1 to 2, but provides very high attenuation for transmission from port 2 to 1. 3. Construction. For application and circulators are used in parametric amplifiers, tunnel diode amplifiers and duplexers in radars. Isolators are used in the output of an amplifier that is sensitive to its load conditions. In UHF or VHF transmitters. In radio transmitters.